Okay, here's some more examples out of your notes, okay, on how to balance a reaction using oxidation numbers. So this one, that's all just one example, kind of just written in different ways, or like just going through the steps that you take. So chloride ions or chlorate ions and iodine react in aqueous solution to produce chloride and iodate. Balance the equation for the reaction. Okay, and then, so the first thing we want to do, again, step one is write down what we have. So we have chlorate, ClO3 minus aqueous, is reacting with iodine, I2 solid, and that's going to produce chloride and iodate. So all of those can be found on your periodic table. Okay, so that's kind of our basic shell of a reaction. Okay, we aren't going to worry about, like, I know we'll have to add in some waters and some H pluses because we have acidic solution. We're going to worry about that later. Okay, so the first thing we have to do, assign no, or oxidation numbers. So Cl is going to be, or sorry, start with O is minus 2. So when we get minus 6, we have to end up with a negative 1 charge. So this is going to be plus 5. This is, again, an element, and so it's 0. This has a charge of minus 1, same as charge. And then this one, we got O is minus 2, so minus 6. So this is going to be plus 5. And that's what it says here. A chlorine atom is reduced from positive, or going from plus 5 to minus 1. So we got a change of 6 electrons. Iodine is oxidized from 0 to 5. So we're going to record the change per atom. So again, we have 6 electrons per chlorine. Okay, because there's 1 chlorine in the chlorate, we have 6 electrons transferred per chlorate. Okay, for this one, we have 5 electrons transferred per iodine. Because there's 2, we're going to have 10 electrons transferred per I2. So we need to find a common multiple between 6 and 10, okay, which would be 30. So we're going to have to times everything in this by 3, and everything in this by 5. Okay, again, whatever we times it by to get the equal number of electrons, that's what becomes our coefficient. So this would become a 3, this would become a 5. Okay, so that's when we multiply by the simplest whole numbers, we can write the coefficients of our reactants. And then from these, now we just balance our products. So we have 5 chlorine, we have 5 chlorine over here. We have 6 iodine, so we need 6 over there. Okay, but now if we look, yeah, we have, like, for oxygen, we have 18 on this side, we have 50 on this side, so we need to balance out our oxygen. Now that's where we're gonna add in our waters and our hydrogen. So now we just use that. So yeah, because this occurs in an aqueous solution, we can add water molecules to balance the oxygen, and then we can add the H plus because it's acidic solution to balance out our hydrogens that we add when we add water. So yeah, again, we have 6 times 3, so 18. So we need 3 more, sorry, 3 H2Os. On that side, so now our oxygens are all balanced out, but now we just added 6 more hydrogens, so we're going to add 6 more hydrogens to that side. Okay, and now we have a balanced redox equation. Okay, we'll do a couple more examples on this next page. I'm going to go ahead and write in all the oxidation numbers as step 1 for A, and we'll go from there. Okay, so I just rewrote it here and wrote the oxidation numbers in, just so I had more room. I didn't have to try and fit them under here. Okay, so now we look at what changes oxidation number. So chromium's going from plus 6 to plus 3. So there's a 3 electron change per chromium. Again, because we have 2 chromiums, we have 6 electrons transferred per dichromate ion. Over here, we're going from chlorine's going from -1 to 0, so there's 1 electron transfer per chlorine, meaning, and since we just have one electron per chloride. Now we balance these out, so times these by 1, times these by 6. That's what number comes up here. Okay, again, we don't have to write the 1, just throwing it there as a placeholder. Okay, now we just look and balance. We have 2 chromium, 2 chromium. We have 6 chlorine, so we need a 3 here to give us 6 chlorine. Now we need to balance our oxygen, so we're going to add some water. We're going to add 7 water molecules to balance out our 7 oxygens. That's balanced. Now finish off, we just added in 14 extra hydrogens. So we need 14 hydrogens on the other side, and we can add that in. Okay, we're just assuming, yeah, it says they're all in acidic solutions. Okay, next one, again, I'll write it out and write the oxidation numbers in the start. So there's our reaction with the oxidation numbers. Now we look at what changed. So iodine's going from +5 to 0. So we have a 5 electron transfer per iodine. Because there's just one, we have a 5 electron transfer per iodate. And then over here, sulfur is going from +4 to +6. So there's a 2 electron transfer per sulfur. And again, because there's only one sulfur in our SO3, in our bisulfite, then it stays the same. Now find a common multiple that we can times them by. So we're going to times everything in this by 2, everything in this by 5. That's our numbers that come up here as our coefficients. And now we just balance out. We have 2 iodine, that's balanced. We have 5 sulfur, so we need 5 sulfur. Okay, once we have that balanced, now we look at our oxygens and hydrogens. Okay, so we have 6 oxygens plus 15, so we have 21 oxygens on this side. We have 20 oxygens on this side, so we need one more oxygen. So we'll add in 1 water molecule. Okay, now we have 2 hydrogens on this side. We have 5 hydrogens on this side and 1 side. So yeah, we have 5 on this side, 2 on this side, so we need 3 more H pluses to balance it out, and we can just add those in. Okay, and then our last example here. So here we have, again, hydrogen's always +1, so then Br is -1, hydrogen's +1, oxygen's -2, so sulfur is +6, and so on. Okay, we look at what's changing. Hydrogen's +1, and we don't have hydrogen on this side, so we know we're going to have to add that in later. Bromine's going from -1 to 0, so we have a 1 electron transfer per Br, 1 electron transfer per HBr. Over here, sulfur is going from +6 to +4, so there's a 2 electron transfer per sulfur. And since, again, we just have a 1 sulfur here, there's 2 electron transfer per H2SO4. So now, again, looking for a common multiple. In this case, it's 2. We're going to times this by 2, times this by 1, which means we'll just leave that, put a 2 in there. Now we want to balance everything that's not hydrogen or oxygen, so we're going to balance bromine, 2 bromine, 2 bromine. We have 1 sulfur, 1 sulfur. Those are balanced. And now we need to balance, we'll balance oxygen next. So we have 4 oxygen on this side, 2 oxygen on this side. So we need 2 more oxygens, and we get those by adding in waters. And now we balance out our hydrogen. We have 2, 4 on this side, 4 on this side. They're balanced, and that's our balanced reaction. Okay, one other thing I wanted to show you is you'll get some questions there just like asking for, is this a redox reaction or not? Okay, so all you have to do, okay, real quick way to do it is write out the oxidation numbers for everything in the reaction. So when we write out these oxidation numbers, we can see like sodium stays +1, sulfur stays +6, oxygen's -2 on both sides, okay, and same with like everything else is the exact same on both sides. So this would be a not redox reaction. Okay, and so then when we're looking at like the concept organizer, how we balance the reaction, we start, write the unbalanced net ionic equation, okay, assign oxidation numbers, identify the oxidizing reduced agents, or oxidizing agent, reducing agent, or just what is oxidized, what is reduced. Find how much they're increased or decreased by. Find the lowest common multiple. Okay, those numbers go as your coefficients, whatever you multiply it by to get the lowest common multiple. Okay, then you balance everything that is not oxygen or hydrogen. If it's under neutral conditions, okay, you just balance other elements by inspection, and then you're done. If it's under acidic conditions, you have to add your waters and your H pluses as you need them. Okay, and we aren't going to worry about basic conditions. Okay, that's all the notes for chapter 13. Okay, hopefully it helps you.